The idea of quantification this week in a relatively simple way. As a general rule, quantification has to do with ways of expressing quantity, as you might guess, in our sentence logic. And then, again, we'll have more elaborate sorts of quantification later when we get to predicate calculus. So as I say, in general, quantification refers to methods for expressing quantity within symbolic logic, whether we're in sentence logic or in predicate calculus. And then most of what we do with quantification will come up later when we introduce, in the predicate calculus, we'll introduce two different quantifiers. There'll be new symbolic notations that you'll get used to using. One is the so-called universal quantifier, and the other one is the existential quantifier. Universal quantifier basically helps us express sentences like every, well, the word every or all, every member of the class did well on this quiz, for example. Every member of the class is really adept at doing truth tables by now. To represent that particular kind of sentence, we would use the universal quantifier if we wanted to say that there existed at least one person in the class who really wasn't comfortable with doing truth tables. That's an existential quantifier. It says that there's at least one. We'll get those later when we get to the predicate calculus. And then beyond this course, if one were to go on to second order predicate calculus and beyond, if one were going to set theory, for example, one begins to get a facility that would allow you to express not just simple sorts of existential or universal quantification, but those particular tools will allow us to, with some reservations, place foundations under all of mathematics. So we can see the logic within mathematics. And that's one of the uses to which those quantification tools have been put in the 20th century as people have sought to see what the linkages were between logic and mathematics. It turns out they're a little bit more complicated than first suspected. Originally, people had the intuition, mathematicians and logicians alike had the intuitions that possibly one might be able to write logic in such a way so that it would provide firm foundations for a perfectly complete and perfectly consistent mathematics. In the 20th century, there have been some results that sort of have been disappointing in that regard, but they have opened up a world of other interesting issues. But for now, forget about the universal and existential quantifiers and forget about all of mathematics, which would come later. For now, I just want to just introduce the idea of quantification by looking at some strategies that can be used within our SL, our sentence logic, or propositional logic, as sometimes it's called. All right. As a general strategy for symbolizing anything in SL, quantities and quantification language included, the brute force method, as it's called in the Logic Cafe, will always work. In other words, you can always translate any sentence by drawing up its truth table, all of the different truth possibilities and combinations of them, and simply writing down a disjunction of the rows that make that sentence true. Let me seek to make sense of that with an example. Why don't you take this sentence? This is a very simple one, and I'd like you to just try your hand at symbolizing that. And the quantification here, of course, is the phrase "at least one." How would you symbolize that given the tools that you've got so far? Should not be difficult. Give me a recommendation, anyone. Just simple, who's got something that looks simple to them? So, right, we're going to have to group this in certain ways. So it's A or Q or Y. It's as simple as that. That's an easy one. How many of you did that one? Okay. Let's say, though, that this is a very simple one. It's easy to intuit. But what you're doing is you're relying on your intuitions in that case. You're saying, aha, I hear what that means, or I understand what that means. I'm going to, it just means that it's either A, or it's Q, or it's Y. It's at least one of those. Maybe more, maybe less. That's all allowed for in that particular formulation, A or Q or Y. But to illustrate this particular general strategy, I want you to imagine that you didn't have those intuitions. I want you to consider the possibility of a more complicated kind of sentence where you're not quite sure how easily to symbolize it. We will see a couple more examples in the course of this morning's class. We'll see a couple more examples where I think your intuitions will be a little slower. It'll be a little harder to be sure what the right symbolization would be. And in those cases, you want something that's a little more mechanical if you could possibly get it. So let us now do this. What I want to do is to sort of just chart down. I'll do this very quickly. Look at all the logical possibilities as you would in a normal truth table. Okay, now look at this recommendation over here, the strategy, the brute force method. Look at that carefully and ask yourself, well, what would that suggest that I should do? Greg.
Make a sentence that's only false if all of the things are false.
Now that's actually doing the right thing. You're streamlining a little bit, but what would this actually suggest, literally? A disjunction of all of the lines in the truth table in which at least one of the three is a province. So that would include which lines? 1, 2, 3, 4, 5, 6, and 7. So what this brute force strategy would recommend is a very, 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 very long disjunct. It would go A and T and Q properly grouped and bracketed, or A and Q and Y. I'm getting the wrong thing. A and Q and Y properly grouped and properly bracketed, or A and Q and not Y, or blah, et cetera, et cetera, et cetera. And that would be a very, 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 very long disjunct. But you could be confident that if you did it that way, it would be right. It would be right. All right, now the corollary to this rule, though, is to follow what Greg's advice. I mean, you notice on this one, on this particular truth table, that there's only one line in which the thing isn't true. The sentence is fulfilled on every line of the truth table except the last. So what's the strategy again, Greg, in this case?
To make a sentence where it's only false if everything is false.
Well, what you do is you negate this one. You say it's not this one. That's what you know. It's all the rest are right, but it's not this one. So one way of writing that down would be not A and not Q and not Y. Right? So that's sort of a corollary to this general rule. You could either, I mean, I suppose what you basically want to sort of watch out for is which predominates in a truth table. Is it the lines that that qualify as reasonable possibilities under the candidate sentence, or the ones that don't? And if the number that where the sentence comes out true, if that number, if there's a smaller number of lines on the truth table where that's the case, then you'd follow the brute force method as written. I want to just show you briefly that the truth tables for A or Q or Y, the simple solution, there's the main connective right here, is the same as this one. T is all the way down except for the bottom line, which is F. T is all the way down except for the bottom line, which is F. So that the simple solution to at least one of them is a province, which was A or Q or Y. That's logically equivalent by our definition of logical equivalence as judged by truth tables. It's logical equivalent to this longer one, which is done by the corollary to the brute force method. Did you finish it? Okay, we'll take it at a time. Okay, so that I hope that's fairly straightforward. So now I'd like you to try a slightly different quantification problem. Try that one. Suggestion?
A and Q or A and Y or Q and Y.
Any commentary? What if we were to use the brute force method? Because this is correct, but that's once again because of your logical intuitions, and you're able to look at this and say, yes, I can see how to do that. We don't need to speak about one of these. I mean, that satisfies it, but it also satisfies yours. So we would have a disjunction of this one, and this one, and this one, and this one. So there'd be 4 disjuncts if we wanted to follow the brute force method, but that would get us something equivalent. And the reason that's equivalent is because when you say A and Q and Y, which is line 1, well, that's already covered by A and Q and A and Y, right? All right, one more. Any questions about these at least ones? Try that one. What's the solution? Anybody? Pete Lowry? Oh, go ahead.
I have A then not Q or Y,
A then? If A then?
not Q or Y. Well, I had not on the outside of the brackets.
Oh, I'm sorry, not, I see what you're saying. Q or Y, right?
And I just repeated that with Q instead of A and Y. instead
But what's
of
the
A.
connective?
Or connected?
Yeah, what's next? I know that I understand the part about how you repeated with the other two, but it's a wedge, right? It's or, right?
Yeah.
Or.
And then
B then not A or Y, or B, not B, Q, or Y then not A or Q. Is that what you had?
Yep.
Is that sufficient?
It doesn't work because anytime one of them is false, that statement is true.
Well, what if it was, this says if it's A, then it's not Q or Y, and if it's Q, then it's not A or Y, or if it's Y, then it's not A or Q. But that allows for the possibility that it's none of those three, and that the sentence says it's certainly not that. So something else has to be added.
It's not A and not Q and
But the thing we had before, this is one of these three is propositions, the very first one we did, has to be added in there somehow, and I hate to proliferate and A or Q or Y. So that says one of them is, the other part says, but not more than one of them is. And so now we've got the whole, that's one way of doing it. Does anyone see a shorter formulation captures all of that? Well, in this case, the brute force formulation would be a little bit cleaner. I mean, if you just simply summarized the three lines using ampersands, you would go, well, it's not that one because that's got three of them. That's got two of them. That's got two of them. This has got one of them. All right, so A and not Q and not Y. That's one possibility. Or not A and Q and not Y. Or not A and not Q and Y. And that's the brute force method. That should capture it. You say
I don't think that works.
this one here, the big one.
Yeah, because if you have A being, say, false, and Q.
No, wait. We don't. We. All right, wait. First of all, let's just do the way I would do this if I were trying. If my intuitions were at work here, and I was trying to do it your way, what I would think first is, well, at least it says that one of them is. So we know this: A or Q or Y.
But do A is false, Q is true, and Y is true?
This says no. This says that if Q is true, then both A and
But
Y
it's
are
or.
false.
But it's or. It should be and.
Ah, I think you're right. Yeah, that's correct. So it's all of these are, and I may have put that into your. I don't know. I asked you about the connective. What connective had you put?
I actually just wrote all three of them in the line, and I didn't add a connected.
Well, that's a way of saying and. So you probably had it in your mind. I think you had it right. Thank you for the correction. But that's correct. I mean, this says, one, if it's A, then it's not Q or Y. Furthermore, and If it's Q, then it's not A or Y. Furthermore, and if it's Y, then it's not A or Q. And furthermore, it's at least one of those things. But as I suggested, still simpler would be just to read it off the brute force method. One is A and not Q and not Y, or, this time it's or, Q and not A and not Y, or Y not A and not Q. Check that. I think that's right. Okay, so this is one of the things that you will be asked to do in some of the exercises this week in the Logic Cafe, is to sort of figure out some of these quantificational questions. And one reason for my going through them specifically here in class is because in the past, students had trouble with trying to figure out how to do that. And I want to just remind you that you can always use the brute force method or its corollary if all else fails, if your intuitions fail you. And you could also, if you have a pair of ways of potentially doing it, you can always compare those two ways by using truth tables and seeing if the truth table comes out the way you want it to, given what the sentence says and given the brute force method. Any questions about any of that? Okay. All I want to do today is to rehearse some of the more problematic connectives in the translations, because the work you're doing in week 4 is once again translating into our symbolic logic some English sentences. And there's at least one problem, there's one problem that I see with the way that the Logic Cafe does it. I want to make sure you remember it. And then there's at least one new thing I want to raise this time, which comes up in the exercises this week, and I want to make sure you've got that too. So, with that in mind, I would like you to work out these 5. We've got 2 screens of 5 questions, and be very careful with the underlined parts. Those are the things that I want to remind you of and call your attention to. Does anybody have any problem with that? Or does anyone see? Yes, sir.
I don't get it.
Okay. How would you symbolize if and only if? Okay. Think about just in case, and think about its meaning compared with if and only if, and then compare it this way. What if I said this? What if I said, Sam, Ames is a politician in case he's disreputable, or in the case that he's disreputable? What would that mean to you? In symbolism. Anybody? What if I said it? In case Ames is disreputable, he's a politician. How about that? Does that help?
Implies.
Yeah, it implies. Which implies which? In case he's disreputable, he's a politician.
Disreputable implies politician.
Yeah. So that one would be, I'll just write it over here. If I said, Ames is a politician in case he's disreputable, that's just a different word ordering from in case Ames is disreputable, then he's a politician. So it's not C. So that would be D horseshoe A. And number one, the way it's written, is saying that, but it's saying something else. It's saying not only is Ames a politician in case he's disreputable, which is symbolized by that, it's saying it's just in case. It's only if he's disreputable. So this is exactly like if and only if, to say just in case. And so that's why I wanted to highlight this, is because it has caused trouble in the past. Just in case simply means if and only if, and is properly symbolized by the triple bar. Does that help at all, Sam? Okay. All right, now then, how about 2, Sam? What'd you do for 2?
Not D implies A.
Yep. What do you have to say about that, folks?
A
Nathan.
implies not B.
Okay. You suggest A implies not D. Why not Sam?
Because Ames is a politician only if he's not disreputable. So the fact that he's a politician would imply that he must be disreputable.
Not disreputable.
Yeah.
Mm-hmm. That's correct, only if, as a general rule, always indicates that the thing that's being qualified there, in this case, if he's not, only if he's not disreputable, that thing is going to be in the consequent. So Ames is a politician only if he's not disreputable should come out this way. A horseshoe curl D. What if we'd said Ames is a politician if he's not disreputable? Then it would be curl D horseshoe A. That would be the if. So in other words, that's just the flopping around of the sentence. If he's not disreputable, then he's a politician. This one says, if he's a politician, you can be sure that he's not disreputable, because he's a politician only if he's not disreputable. So therefore, the correct symbolization for this sentence is that. Is that still evading your logical sense, or does it make sense?
No, that's fine.
It's fine, but what? Does it seem arbitrary to you?
There's just too many different ifs. There's like if and then only if and then if and only
But those-
and they each mean like different consequences.
But they do mean that in English, don't they?
I don't know, I never thought about it.
Okay, all right. Number 3, Mark?
Is a necessary condition. I wrote B horseshoe E.
That is correct. Is there any commentary or questions about that one? If you say necessary conditions, those two. Go in the consequent, on the right side of the horseshoe. And notice for those few who used what is basically set theoretic inclusion, sometimes people on quizzes have written that. That's incorrect. I didn't mark. That's not our horseshoe. But that is actually set theoretic inclusion in some notations. So perhaps that's why you wrote it that way. It plays a similar role to horseshoe in some contexts, but not all. And what I want you to get used to writing the horseshoe properly. And you can think of it as, if you want, it's like a little arrow, and we take the head off the arrow. That's our horseshoe. And it's that might help remind you which way it goes. All right, so what we find is that the necessary conditions go in the consequent, but once again, the wording might throw you off here in number 3 also, because in this case, it doesn't say, it's a necessary condition of Bates's being emotional that Bates be emotional in order for her to be a politician. It doesn't say it in that word order. It says Bates is being emotional is the necessary condition. But since that's the necessary condition, it goes in the consequent, because it would have to be true in order for the implication to come out true. It says here. All right, how about number 4? Luke?
A or not C.
All right. Unless we are interpreting, this is the one that I have trouble with, but we are just going to take Logic Cafe's word for it that unless means simply wedge, means simply or. Okay, now finally, here we go with the sufficient condition. What's number 5? David Zappelli.
I said A horseshoe D.
And that's correct. Sufficient conditions are antecedents. Any questions about that one? Okay. One more page of these. Okay, once again, do those. These are on the one hand more complicated, but there's one new thing here that will prove important this week. Okay, let's start with number 1, Chris Fisher. What do you got?
I said B or E.
In parentheses, right?
Or not A.
Where do you stop? What's going on? You said B or E or curl A. And of course, the B or E could be in either order, it doesn't matter. But yeah, that's where, once again, the unless. So we're saying either Bates is emotional unless she's a politician, or Ames is a politician. Any questions about that one? All right, number 2, Alex Minor, please. What'd you do?
Go back a page real quick.
Pardon me?
Just had to go back a page. You got in parentheses, if C, then not F, and then outside the parentheses, or, and in the parentheses, not E, then B.
Not parenthesis? Or is it not E?
In the parentheses is the not E.
I'm sorry, where's the not?
Inside parentheses.
Okay, so. And then what?
Then B.
Now this says either if Connor is a politician, then he's not fastidious, or, so either that, or if Bates is not emotional, then she's not a politician. Nathan?
I had not the quantity C implies F.
Oh, so wait, you had not over here on the left, or is there more differences?
More differences.
Okay, so I think this says the wrong thing. So it's not either. It's going to be a not something. And then what do you have, Nathan?
Not the quantity C implies F. And not the quantity B implies E. Other way around.
D implies E?
Yeah.
Why that? It's
Well-
supposed to be, now it's sufficient conditions. What do we know about sufficient conditions? Being emotional is the sufficient condition. It says, it says neither is, now forget about the neither for a second. Neither is being fastidious necessary for, okay?
Okay, yeah,
So,
switch that.
that's correct. There's another way of doing it also that sort of captures the English a little bit better. But this says, because neither nor comes the same thing as not either, right? So this is not C implies F and not E implies B. So once again, we got the necessary condition over here of being fastidious. That's on the right, as necessary conditions always are. And over here, we have emotional being sufficient. It's a sufficient condition. It goes on the left, as sufficient conditions always do. And this says both of those two molecular sentences are false. And you could have written it this way. Shouldn't write too big. Well, so that's a correct solution. Anybody have another one that solves that number two? A different way of doing it? Ah, Nathan, yes.
Not parentheses.
I'll put a bracket.
Okay. C implies F. And then still in the bracket, or E implies B.
And that's another correct solution. That actually, I think, better captures the English, but it doesn't make much difference. They're both logically equivalent. And later on, we'll learn a rule that says that if you ever have a not disjunction, like here, you can convert that into a conjunction of two nots. Those are logically equivalent. All right, number 3, Adam.
Parentheses, A implies D implies not parentheses C and F.
Okay, I'm concerned about the left side. Once again, we have an only if.
Oh, D implies A.
Yeah. Do try to get used to that just as a convention, but also, really, as I've said before, try to see that it makes logical sense. Try to see that that is the meaning of these things. And you're grinning over there in the corner. You find it difficult to see that, or?
It's not that difficult.
Okay. I mean, where it just sort of defies intuition, that's something useful to talk about, whether it's in our discussions or in class. It's useful to sort of raise questions about things that just don't seem to be right, intuitively speaking. Any questions about 3? We've got Ames is disreputable only if he's a politician. If that's the case, then it's not the case that Connors is both a politician and fastidious. Only ifs go in the consequence side, on the right side of the horseshoe. All right, any questions about that? All right, Nathan, you want to try number 4 this time?
C or F, or the quantity C or F.
Oh, yeah.
And the quantity F implies A.
Oops. I would have written more. Because there's a, she's not a politician. You're not including that. So I think you just sort of omitted that part, right?
Yeah.
So we got F implies, what would you say?
Where is she? F implies not C and A.
But what I want to point out now is this in which case thing. These in which case words. Did anybody else get that correct? Did anyone get that right? Good. The in which case formulation throws almost everybody the first time they see it, and you'll see it a few times in the Logic Cafe and possibly on the quiz on Monday. In which case refers to if she's fastidious, right? Not to the whole thing, but just to the fastidious part. It says Connors is a politician unless she's fastidious. And then you might as well say And if she's fastidious, then she's not a politician, but Ames is. Is that clear? Okay. So watch out for those, yes, sir?
The only thing I had different is I put the C or F on the other side on the right. Is that wrong?
You put, wait, so you put, it was like this? Like
Yeah.
that? Nothing wrong with that. You can always switch, conjuncts around, or you can also switch, the two sides of a wedge around, because you're saying this and that, you might as well say that and this. It becomes the same thing. So if you have this answer, that's fine too. Okay. Peter, number 5.
I have the term E or C. If E or C, then D triple bar A.
Okay, here we got the unless again. That's again something I want to keep hammering in. We're going to use wedge for unless. And then the first occasion, and at least these several exercises of if and only if, that's the triple bar. Does anybody have any questions about this? Okay, these are the sorts of exercises you'll be working on this week. And frankly, I mean, it doesn't go very much beyond what you did before. It just adds some of these little wrinkles. Do all the exercises in the Logic Cafe every week. Do that this week. I'm done for today. I'll hang around. If you want to stay here and work in the Logic Cafe, that would be an opportunity to get ahead for week 4. Otherwise, if you would prefer moving to some other locale where they might have coffee or something like that, that's excellent too. So whatever you want, class is dismissed.